Hi everyone, welcome back to Calculus 3. In this video, I am going to discuss vectors in space. First, let me discuss three-dimensional coordinate system, or we call 3D system. If you watch my previous video, you already know the 3D system. As I mentioned over there are two types of 3D system. Right-handed system and left-handed system. Let me draw the coordinate system. This is x, y and z. In 3D system there are three axes, x, y, z, and here I change x and y axis, so y, x, z. So this first one is called right-handed system. Second one is the left-handed system. So what is the difference between these two? Actually here x and y axis are changed, right? You see x axis is here, y is here, and here y axis and x. In this section we are going to use right-handed system. Therefore let me discuss right-handed system. I can extend this one into this direction. 1, 2, 3, those are positive values of x, and here are negative values of x. Similarly, y-axis, these are positive values and here negative values. So z I can extend down here, so negative values are here and positive values are here. So we know these three axes are perpendicular to each other. How do we write the point? In the 2D system we use x, y, but in the 3D system we use x, y, z. Let me talk about points. X, y, z, and I extend this one negative, so this one over here negative and here negative. So how about point A, 1, 0, negative 4? How do we plot this? Okay, so x, 1, 2, so on, y, 1, 2, 3, so on, 1, 2, 3, here negative numbers and negative numbers of y, here negative numbers of z. This is the x value, x equal 1, y equal 0, z equal negative 4. Okay, x equal 1, you start from this and come to the 1, then y equals 0, then we don't go anywhere at this point. We don't go anywhere because y equals 0. So then we know this point, at this point x equal 1 and y equals 0. But still we need z equal negative 4. We know z-axis is vertical and negative 4 from here to here 4 points. So what I do, you can actually take the 4 units from here to down, and we can draw a line to parallel to the x-axis and line from here parallel to the z-axis. Then the point they meet at here, so this is the point a 1 0 negative 4. Let me discuss another example. So I use XYZ coordinate system. So you know we have negatives, and as an example I use B 2, 3, 4. Then how do we draw this one or plot this one? Actually x equal 2 and y equal 3. So come to the x point, this is 2 and y is 3 here. So what we do, I draw a line parallel to y at x equal 2. Then I draw a line parallel to x at y equal 3. So then this is the point x equal 2 and y equal 3. Then we need to go up 4 points. So you can go up 4 points from this point. Let me write down here 1, 2, 3, 4. Or you can use another method. Let me explain what you should do. Draw yourself the line segment that intersects the origin with the projection of the point. It means this. Intersects the origin with the projection of the point. And we draw another line to parallel to this green one at z equal 4. Like this. Now we start from this point and let me use red color, this point, and go up until we meet that point and that line. So this is the point B, which is 2, 3, 4. As I explained in my previous video, you already know there are 3 planes in this system. What are those planes? YZ plane, XZ plane, XY plane. Let me show you. So this is the 3D coordinate system at your right-hander system, XYZ. So now you see very clearly XZ plane, YZ plane and XY plane. In the XZ plane, what is the Y value? In this plane, Y value in this plane, Y value is Y equals 0 always. In YZ plane, X equals 0. In XY plane, Z equals 0. Now think about X equals 3. What is the X equals 3? In the 2D system, X equals 3 is a line. You already know it. But in the 3D system, is it a line? No. In the 3D system, x equals 3 is a plane. So, it is a plane cut through the x-axis at 3 and go all the way to parallel to YZ plane. Suppose this is the 3 here, that is the x equals 3. So let me use green color. So this is the x equal 3. So the plane cut through the x-axis at 3. So like this. And go all the way parallel to YZ plane. Actually, so parallel to YZ plane, actually it should be parallel to this one. So like this. So you see like this. And the plane here, okay, here like this. So that is the positive side of Z value. And then from this, actually go this way, you see After this here, we can draw like this. That is the negative value of this from here. So that is the x equal 3. Now I plot z equal 4. What is the z equal 4? Z equal 4 is a plane go through at z equal 4 and parallel to the xy plane. So it should be something like this and this. Actually this is the 4, so this go through actually 4. It means you see that it cut the z axis at 4. Next, distance. How do we find the distance between two points in the space? Suppose there are 2 points P1, X1, Y1, Z1 and P2, X2, Y2, Z2. Then distance between P1 and P2 is x2 minus x1 squared plus y2 minus y1 squared z2 minus z1 squared and square root. So this is the distance between 2 points in the space. So it's better to understand the proof of this. So let me explain the proof. XYZ coordinate system, x, y, z. So P1 is x1, y1, z1 and P2 is x2, y2, z2. So we are looking for the distance between P1 and P2. I use D for the distance for the P1 and P2. Then this is a 3D. So let me complete the diagram here. So this is the complete diagram for our proof. So let me find some points. So here I use this one Q and this one R. So what is the coordinate, or what are the x, y, z values of Q? You know this PQ. So P1, actually P1 Q is parallel to y, therefore x values are the same of the both, therefore it should be x1. Z values are also the same, but only change is y value. But you see P2 y values is y2, so P2 and Q y value must be the same, therefore this should be y2 and z1. So R x values is changed because QR parallel to x-axis. P2 x values is x2. Therefore, this should be x2. And how about the y value? So y doesn't change. That should be the same of Q, because you know this QR is perpendicular to y-axis. Therefore, this is y2. Then z value is z1, the same of q. Consider the PQR, P1QR or P1RQ triangle. Q angle is 90. Therefore, P1QR is a right triangle. Now let me find the P1Q distance. What is the P1Q distance? You see y coordinate is the only change. Therefore, that should be y2 minus y1. Now consider the QR. What is the QR? Over there we change only x coordinate. Therefore, that is x2 minus x1. Now consider again P1QR triangle. So let me draw here. Actually this is just triangle now, like this. This is P1 QR. Actually this is 90, right? So then how do we find the P P1R distance, P1R. So if this is 90, we can use Pythagorean theorem. So P1R equal P1Q power 2 plus QR power 2 and square root. So using that, we can find the P1R using these x and y values. So y2 minus y1 to power 2 plus x2 minus x1 to power 2 and square root by using the Pythagorean theorem. Right. Then how about the P2R? P2R or P2. Yes, here you see x and y values are the same of the P2 and R. Therefore, it change only Z1 and Z2. Yes, it is vertical and parallel to Z-axis. Therefore, that distance we can find Z2 minus Z1. Think about P1, P2 R triangle. So if I draw that, you see P2 are this and P1 are like this is the P1, this is R, this is the P2 and P1, P2 this. We know these two are perpendicular and we know this one Z2 minus Z1 and this one we know P1R, it is here. So we can use Pythagorean theorem for this triangle now. So let me use that to find the P1, P2. So that is the D, this equal P1R is y2 minus y1 square plus x2 minus x1 squared and this is square root again second power, then plus P2R power 2, so that is Z2 minus Z1 to power 2, then get the square root. That is the proof of our theorem. This is the P1, P2 which is the same here. Now let me explain an example. Suppose there are 2 points, 2, 3, negative 1. I say that is P1 and P2, 0, 1, negative 2. Then how do we find the distance between P1 and P2? P1 and P2, I say simple D. So this is 0 minus 2 to power 2 plus 1 minus 3 to power 2 plus negative 2 minus negative 1 to power 2 and square root. When you simplify this, here you see 4 plus here also 4, right? 4 plus here 1 square root which is 3. So that is the distance between P1 and P2. Next, let me explain how to find the midpoint of a line. Midpoint. How do we find the midpoint? Yes, let me explain that in 2D. P1, x1, y1 and P2, x2, y2. So what is the midpoint here? How did we find x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So then how do we find the midpoint of P1 and P2 line in the space? So we know x1, y1, z1, here x2, y2, z2. Anybody can guess? I think yes, you already know that. But let me tell you, this is x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. So that is the midpoint. Equation of the circle is x minus h power 2 plus y minus k power 2 equal r squared. Here h and k are the center. Here h and k is the center of the circle and r is the radius. So this we can extend in 3D, then it become sphere. So what is the equation of the sphere then? Yes, it is the actually extension of 2D x minus h to power 2 y minus k to power 2 plus z minus l to power 2, and radius is the same r. It means what is the center of this then? Center is h, k, l. Center of the sphere. So what is the radius of the sphere? Here is the same, which is r. Okay, so this is the equation of the sphere. Now let me explain an example using these concepts. Example. So I say find the standard equation of the sphere, okay, that has the points 5, -2, 3 and 0, 4, -3 as endpoint of a diameter. If I draw actually this sphere thing this way, I cannot draw exactly like this. So then one point is here, other point is here, and this is endpoint of a diameter. So this is the diameter which is going through the center. Right, they're asking the equation. So how do we find the equation of this sphere? Okay, this is the way. First we will find the center, because to find the equation we need center h, k, l, and we need a radius. So center is the midpoint of a diameter. Therefore we can find center 5 plus 0 divided by 2, -2 plus 4 divided by 2, 3 plus -3 divided by 2. So this is 5 over 2, 1, 0. So this is the center of this sphere. Right, then radius. How do we find the radius? To find the radius, we can use the distance formula in 3D, right? What is the distance formula? x2 minus x1 to power 2 plus y2 minus y1 to power 2 plus z2 minus c1 to power 2 is square root. So if I plug the numbers here, 0 minus 5 over 2 to power 2 plus 4 minus 1 to power 2 plus -3 minus 0 to power 2 and square root. So this is root 97 over 2. Now we know the center and the radius. Therefore we can plug or we can use the sphere equation. So that is x minus h. H is 5 over 2 squared plus y minus k. K equal 1. Therefore this, and actually here you see that this is the h, this is the k, this is the l. So l equals 0. Therefore z squared equal r to power 2 because you see here r to power 2, therefore 97 over 4. Now standard unit vectors in space. How do we find the standard unit vectors in space or in 3D? Yes, you know in the 2D, I and j. I was 1, 0, j was 0, 1. Then can you guess here? Yes, here again we have 3 axes, x, 3 direction, y, z. So then unit vector in x direction, actually we use the same I, and unit, this one is 1, 0, 0, that point. So unit vector in y direction we use j. So this point 0, 1, 0. Now we have unit vector in z direction, positive z. So then it is actually k. We use k, that is 0, 1, sorry, 0, 0, 1, that is the point. Here we use I, then you know position vector of I, because starting point is origin 0, 0, 0 and endpoint is 1, 0, 0. Therefore we can write the position vector this way. J, similarly we can write 0, 1, 0 and k can be written 0, 0, 1. So these are the standard unit vectors in x, y, z direction respectively. Now suppose you have any vector, I use here, that is v. I say v1, v2, v3. This is the v vector. So we can write v vector in the position vector. What is that? We can write v1, v2, v3, and we can write this one v1 0, 0 plus v0, v2 0 plus 0, 0, v3. So v1, v2, v3 are numbers, so you can take this out. v1 1, 0, 0 plus 0, sorry, v2 here 0, 1, 0 plus v3 here 0, 0, 1. Now you know v1, this is I, and v2 next one is j, and the last one v3 and k. So you can write any vector using the standard unit vectors. Now suppose you have this p, q, again in the x, y, z coordinate system, x, y, z. P, I write down p1, p2, p3, and q, q1, q2, q3. Then this is v vector. So how do we write the v vector? So v vector equal, according to this we can write, you know, v1, v2, v3. We need to find the v1, v2, v3. So v1 is the q1 minus p1, and v2 is the q2 minus p2, v3 is the q3 minus p3. Now let u vector is u1, u2, u3, and v vector is v1, v2, v3, and z is a scalar, which is a constant. Then equality of vectors, that means u vector equal v if and only if u1 equal v1, u2 equal v2 and u3 equal v3. Again, it is the same thing in the 2D, but again we have here, yes, we have one extra value for the z, that's it. Because in the 2D we had only 2 x and y, but here we have 3 x, y, z. Then how do we write the component form? So again we have P, P1, P2, P3 and Q, Q1, Q2, Q3. So then P1, P2 line segment, or we can say V vector represented by the directed line segment of P and Q, sorry, not P1, PQ line segment. So this can be written V1, V2, V3. As I explained before, this is Q1 minus P1, Q2 minus P2, Q3 minus P3. So you know this is the component form and these are the components. Then how do we find the length? Yes, you already know. Length is of the vector is v1 square plus v2 square plus v3 square and square root. Fourth one, unit vector in the direction of v. Let me write down that unit vector in the direction of v. How do we find the unit vector in the direction of v? That is, you know, vector divided by its length, always. So this case 3D 1 over this, then you can write down v1, v2, v3. But you know v not equal to 0 vector. This is a 0 vector. Then how do we add? As the same thing I explained before. I used this, but I didn't explain. So let me write down vector addition. So say v vector plus u vector. So you know we can write down v1, v2, v3 plus u1, u2, u3. So you can add them. v1 plus u1, v2 plus u2, v3 plus u3. So that is the addition. So next one is scalar multiplication. Scalar multiplication. It is also very similar to 2D. CV equal CV1, CV2, CV3. Okay, next, parallel vector. Parallel vectors. So suppose there are two non-zero vectors u and v, then we say u and v are parallel when there is some scalar c such that u vector equals c v vector. So let me explain this actually. Suppose you have u vector, I say 2, -4 and 3, and v vector 8, -16, 12. So you see we can write, I will show you this way. V, here you have common factor 4, then I take 4 out, then 2, -4, 3. So what is this? This is u, so you can write down 4u. Therefore we can write v vector equal 4 times u vector, which is c. By this definition, z equal 4. Therefore we can say u and v are parallel. This is the end of section 11.2.